Okay, so now let's get you to practice on some expressions or some equations. That's what we're doing here today. So I'm going to put a few up, and then I would like you to pause the videos, do the work, use the tiles or solve them in your notebooks, then roll the video to see what the solution is, and we'll do that a few times, okay? So here's the first one I would like you to solve. So let's go with 5x minus 1 equals 24. So go ahead and pause the video and do the work. And here is how I would solve it. There's my 5x minus 1. Oh, there's my 5x minus 1. Then I'll put 24 over here. 1, 2, 3, 4, 5, 6. Oh, having a bit of a hard time here. Okay, chose some big numbers. There. So I've got 5x minus 1 equals 24. So here we go. So what I've just done there is I've added 1 to the left side and 1 to the right side. The zero pair removal cancels out these and leaves me with 5x over here, but 25 here. Division by 5 looks like this, and so I will end up with equal groups in each of these places. So as you can see, x equals 5 because I divided into 5 groups on both sides. So x equals 5. And if I put the 5 back into my original equation, 5 times 5 is 25, minus 1 is 24. Okay, let's do another one. So let's try this time x divided by 3 minus 1 equals 11. Okay, so pause again and try to solve that one, please. Okay, so first I'll model this, and again the division into 3 is going to be tough, so I am going to have to be very, very tricky here. So if I divide this into 3, this is going to be a rough approximate. So I've got 3 sections of my x, and each of these sections is a third. So this third, if I take away 1 from that third, I'm going to end up with 11. So 11 right there. Okay? So the first thing I'm going to do is get rid of the constant, which is my subtraction of 1, and I'm going to do this by adding 1 on this side and adding 1 on this side. So what I've done is this: add 1, add 1. Get a zero pair here so I can remove it. So what I'm left with, and I'll write it down here, is a third of x, which equals 12. So if this third of x equals 12, then it would make sense that this third of x equals 12 and this third of x equals 12. So each of these thirds of x equal 12. So this third of x equals this 12, this third of x equals this 12, this third of x equals this 12. So I'm multiplying my thirds to get the whole x. So I'm multiplying my thirds, I'm going to get the whole x, so I'm going to pull away that whole x there. And so just write that down, I'm multiplying my thirds by 3 to get the whole x, but I end up multiplying 12 by 3 to get 36. And that's what I have over here, is 3 groups of 12, which is 36. So let's pop 36 into the left side of the equation here. As you'll recall, the left side was x divided by 3 minus 1. So let's back that up, and instead of x, let's put 36 divided by 3 minus 1. Well, 36 divided by 3 is 12, minus 1 is 11, and lo and behold, that's what we had over here on the right side. Let's try another one. Let's try negative 4x plus 2 equals negative 10. Pause the tape, try that, then come back and see what it's all about. Okay, so this one's a bit tricky because we have a negative coefficient. So these are negative x's. How many do I have? I have 4 of them. 1, 2, 3, and 4. And then I'm adding 2. 1 and 2. And all of that over there equals negative 10. There. Okay, so as always, we deal with the constant first. That's my positive 2. How do I get rid of positive 2? I subtract it, or I counter it with negative 2. But if I add 2 negatives to this side, I need to add 2 negatives to that side. Okay? So what I've done here, again, is I've subtracted 2 from this side, and I've subtracted 2 from this side. Let me simplify this a bit. So my 2 negatives and my 2 positives literally cancel each other out because they make 0 pairs and they're gone. So when I rewrite my equation, I'm going to have negative 4x equals negative 12 because negative 10 minus 2 is negative 12, and you can see the 12 negatives right there. So we need to do a little division now, right? Because we need to counter the multiplication of x by negative 4 with division. So we're going to divide by the same number, negative 4. And what we do to the left, we do to the right. There we go. So here it is. We're going to separate our space into 4, and we're going to put a negative x in each of these 4s, and we're going to redistribute these negative 1s over here into the spaces. And we are going to hit a catch, because right now it almost looks like we're finished, but we're not. It looks like we're finished because we have one of these variable tiles equaling 3 of these number tiles. Then it would be easy to say, oh, the answer is negative 3. But the problem is we don't know what x is. We know what negative x is. So at this point we know that negative x equals negative 3. But you'll notice up here we divided by negative 4, right? So a negative divided by a negative is a positive. Whoops, I put an X here. I shouldn't have put an X here. That was bad of me. Bad teacher. So negative 4x divided by negative 4 is going to give us positive x, because a negative divided by a negative is a positive. So the answer should be x equals, well, negative 12 divided by negative 4 is 3. That should be the answer. But why do I have this down here? Well, I have this down here. That's actually correct. It's just not complete. I have negative x times negative 3. Now you know that a negative times a negative is a positive, and we want positive x. So I'm going to multiply negative x by negative 1. So x times 1 is x, but a negative times a negative is a positive. So multiplication by negative 1 changes my negative x into an x. What I do to the left, I must do to the right. So I'm multiplying by negative 1 over here. Negative 3 times negative 1 is 3, which is what we had right there. So let's check it out and let's see what happens. So I'm running out of space here as normal. So I've my left side was negative 4x plus 2. If I multiply negative 4x by negative 3 and then add 2, sorry, let's back that up. The actual answer is negative 4 times positive 3 and then add 2. What am I going to get? I'm going to do that over here. So, okay, so negative 4 times negative 3 is negative 12. And when I add 2 to it, I get negative 10, which is our right side. So we're good. Maybe we will try one more. And so I'll put the question up and you can solve it, and then that'll be it for the day. Here we go. Let's try 2x minus 3 equals 13. Okay, so try that out. So give it a pause and try it out, then play when you're done. And we're back. Okay, 2x is here, negative 3 is here. 13 is going to look something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, great. So let's deal with the constant first. So I've got negative 3 over here, so I'm going to counter that with 1, 2, 3 positives. But I need to also put 3 positives over here to make sure that we're maintaining equivalence. So we're going to add 3 and add 3. Okay? But the subtraction of 3 and the addition of 3 cancel each other out, as we can see as the zero pairs go away. So what I'm left with is 2x equals 13 plus 3 is 16, and I have 16 tiles here, so that's great. So now we're going to divide my 2x into 2 sections, and we're going to divide my 16 into 2 equal sections. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So we've just divided by 2 and divided by 2. And we see from the division by 2 that 2x divided into 2 groups gives me x. And x in the circle here, the red loop, is equal to 8. X is equal to 8. And if I put an 8 right in here where the x is, I've got 2 times 8 is 16 minus 3, that's 13, which is what we started with. So we're good.